Sometimes we want to print things out to the output log, which is a tab within the editor that we can inspect, and this is really handy for debugging purposes. As with standard C++, we often want to ensure that certain conditions are met, that certain blocks of code are executed or functions get executed, maybe see what the values are at a certain point in your program, and so forth. So logging is very important. And in the Unreal Engine, we have the UElog macro for logging. We will see some examples later on in this lecture, but to get started, I would like to mention that we have these parameters with the UElog. We have the category name, the verbosity, and then also the format. So what are those? What are we going to pass into this UElog? Well, the category name are different categories used to keep an ordered record of events. Those are set in the core globals header. And it's invaluable for debugging purposes because basically you have different categories of logs. You can have some general temporary log, which is actually what we will use. We'll also see some of the other categories here shortly. But we also have something called verbosity, which is used to control the level of detail present in a given log, because you can print out to the output log in the editor, and you can also print out to a file on disk. The values are defined in an ELOG verbosity enumeration. Valid values that will print to the console and to a log file include display, warning, error, and fatal. Fatal will actually crash and print a fatal error, so we actually avoid using that. Then we also have some values if you want to log to a file only. So log, for example. For more detailed logging, you can use verbose or very verbose. Finally, we have the format, and that is going to be the actual text message that we want to log. Here are some examples. For the category name, I will be using a log temp. We will stick to this for the most part in the course. Then you have display, warning, and error. That is for the verbosity. And then we also use the text macro for the actual text message that we want to display. In the output, we can see that actually displays in different colors as well. For our purposes with the log temp, something does not necessarily have to be a warning for you to use that. If you want a log to stand out from the rest of the logs for some reason, then you can also use warning, for example, and you can see that has that orange color. Display is in gray and then error is in red. So this is an example of the output log that is within the editor. We can also navigate to the project folder, so in this case CPP experiments, and then we can go into the saved folder, into the logs folder. Notice that the files within here have the .log extension. If I open up the CPP experiments _2 log file, in here we can trace the programs who have some timestamps and we have logs, certain log categories. We may have to search to find our log temp. We can do Ctrl F to find. The point with this is very handy for debugging because we can now trace our program. We can see when things get logged in different categories out from blueprints, what game mode was loaded and when, and so forth. Now what's handy about the output log in the Unreal Editor is that it is easy to filter by category and verbosity. The coloring of the verbosity does not show up in a simple text editor such as Notepad here, but it does show up in the editor output log. For this demonstration, in the begin play function of our dummy actor class, I have these log statements from the slides. We can use the log temp category, display, warning, and error for the verbosity, and then some text message. Back in the editor, we have an output log drawer, which is where our log messages will appear. We should not get the output log and the live coding console confused. The output log drawer is similar to the content drawer in that it will close down again when it loses focus. That is when we click on something else. To the left of the settings button, we can click on the Dock in Layout button to get an output log tab in the layout. This is so that we can see the log when we actually play the game, since again the output log drawer will close. If we click on the settings button, we have this toggle where we can select to clear the log on play in editor. This is so that we don't get a huge list of logs that build up over time. We actually also have the option to open the folder that contains the output log files. We can open those up in a text editor such as Notepad if we want to step through our logs. When we play, we can see different logs in the output log, categories such as log blueprint user messages, log temp, log world, and so forth. We can also see that some of the logs are output in gray, some of them in yellow, and some in red. If we want, we can filter the logs so that we can focus on specific logs. We can also filter the verbosity, so whether we want to see messages only, that is the display category, warnings and errors, so we can toggle those, And we can also specify the categories that we wish to show up. In this case, I don't want all of the categories to show up. I will click Show All to uncheck that. Now none of the categories are selected, and so we don't get any outputs in the log. I will filter the categories again, this time searching for log temp, and click on that to check that. Note that you may have to hit play at least once before the log temp will show up in the category section. Now only the logs in the log temp category will show up. I'd also like to mention that you can right click in the output log and select clear log when things get too busy in the log. Now we actually get those log temp logs printed out twice on begin play, and of course this is because we have two instances of our dummy actor in the level. One is an instance of our C++ class, and then the other an instance of our blueprint derived class. If the text in the output log is too small, you can change that in the editor preferences, so you can go to Edit, Editor Preferences, and then navigate to the Appearance section, or you can search for output log. I will change the log font size to 14 to make it easier for you to see that in the video, but you can leave it at 9 if you want, since there are often many logs in the output window. You will get this pop-up that says Restart required to apply new settings, so I will select Restart now. When the editor opens up, I will play, and we will have to apply those filters once more. We want to see log temp, and we can see those display warnings and errors. We also see those printouts that we get, and that is from our blueprint, the dummy actor blueprint class. So before we continue, to avoid confusion, I will open up that blueprint, and in the begin play event, I will disconnect that execution pin so we don't get those printouts and those logs, because those print messages will actually print to the log as well. Of course, you can change that by going to that print node and selecting where you want those messages to display. In the settings, we also have an option to open the output log in an external editor such as Notepad or whatever you have set up for that. Here's another bonus for you. Let's say you are playtesting and would like to bring up the output log. Maybe you don't have the tab open, for example. Well, while playtesting, we can actually bring up the output log within a console. To demonstrate, I will play, and then you can press the tilde key to bring up a console. You may be familiar with this from typing in cheats into some games. This, however, is very useful for game development. We can type in show log and then press enter. As we can see, that will bring up a log in a console window. Currently it is empty since we are not logging anything at the moment, but if we stop playing, it will log the cleanup process. Which we will also see in the output log in the editor, so we can compare those. I have to mention that if you click the close button to close off that console window, then the editor will actually also close down. Also, I'm demonstrating by playing in the selected viewport, but this also works when playing in the new editor window, for example. So keep this option in mind when you are debugging your game. Familiarize yourself with these options since it can come in handy someday. I want to make some comparisons between the standard printf and the UE log. With the printf, we can pass in a character sequence. So we have standard printf, for example, and then we can pass in the name of some character sequence. I also have the function prototype here of the printf function, so we can see we can pass in a character sequence to that. Of course, the UE log is a bit more complicated because that is a macro, and that also takes in multiple arguments. It takes in a category name, verbosity, and then you will actually pass in your text in there as well. But here we can see we have a tchar sequence, so a tchar C string, and we can pass that into the UE log as well. Another comparison using the format specifiers. With the printf, we can see we have the format specifier D for an integer, F for a float, and we can do the same sort of stuff with the UE log, but again you will have the category name and the verbosity followed by the format. So we have log temp here, for example, warning, and then we have the text macro. So it's a bit more complicated. You pass your text in there, and you can also use the format specifiers within that text macro. Following the text macro, we can do comma, followed by variable names, or in this case I'm just using literals. We can also note that as with the printf, we can have multiple specifiers. In this case we have 2 specifiers per log, and you can separate those out with the comma. But with the Unreal Engine log, we are going to do the text macro first. that is going to contain our string basically. We will do comma following that and then provide those values in a comma separated list basically. And of course, as with the printf, the order needs to match. So 255 will be for the D specifier, and then the float will be for the F specifier. If you swap those around, you won't get what you may expect. I'm not going to cover the details of printf in this lecture. You need to be familiar with that already. And you also need to be familiar with the format specifiers at this point. Again, the C++ 1 or 2 module is prerequisite. That is for the Unreal Engine modules. I feel these comparisons will make it easier to understand the UE log and how that works. Alright, so let's continue. Let's talk about how we can log an F string. We've seen we can do a C string, but really we don't want to do C strings. For the most part, we will use an F string because that manages a C string for us. We will actually get an error if we pass in the greeting by itself in the UE log. You can see in the Unreal Engine log I do log temp warning text, and I simply pass in %s here, so the S specifier for strings, so an array of characters. Then for the argument for that specifier, we do greeting, but we don't just do greeting because again then you'll get an error. We actually use the asterisk operator. That is overloaded to return the initial element of the array of characters. That again is managed by the F string. So it is overloaded for that F string class. You can do that instead of doing a longer approach. So greeting, then you do the get char array, because the string managed by an F string is actually contained within something called a T array, which we will discuss in more detail in an upcoming lecture. So the get char array will return a T array which contains T chars, so those characters, and then you can do .get data. But the thing with this is it does not do additional checks, so it does not check if the string is empty or not. We will have to do that outside of the UE log, for example. So instead we will use the overloaded asterisk operator. It seems a bit weird to use it in this way. It is not doing dereferencing. It may seem a bit strange, the syntax, but it is actually overloaded to get that initial element of the array of characters, because that is what the S specifier wants. Of course, as I've demonstrated before, you can have more than just that specifier in the text macro. So let's move on to some additional examples, some of the common logging that you may do in Unreal Engine. I will use the same category name and verbosity for these examples, so log temp and warning, for example. And then we can do different sorts of logs. We can simply print out a text for debugging purposes. So for example, if you want to see a simple log when something spawns, maybe you are spawning multiple things into the level, then on that actor in the beginplay function, you can do a simple log that says actor spawned or apple spawned or bullet spawned or whatever it is. As we've seen, we can also do F string, so you can do an F string and then we have to dereference that to get the pointer to the initial element of the array which that S specifier wants. You can also do integers with the D specifier, floats as well with the F specifier, your int and your float, for example, but of course you can pass in literals if you want. As I mentioned in a previous lecture, it's preferred to use variables where you can to make it easier to read so that you don't use random literals. Then if you want to see whether a boolean is true or false, you can use this sort of syntax. The boolean is %a, so you print out a string, but we can use the conditional ternary operator, and then we can check if it is true, then we print out true, otherwise we print out false. Then you can also print out multiple things using multiple specifiers, as I mentioned before, using the comma separated list. So in this case we have an F string again, some character name, and we're going to print that out. But we also have an integer, so we do %d, so the D specifier, and we pass in some power level, some integer variable. So I hope you find this slide useful. It lists all of the common logging that you will do. Of course, you can also use the escape characters such as new line, \n, for example. If you want to do tabs, then you can do that as well, and so forth. And of course, again, if you are familiar with the printf, you don't have to add these at the end, which should also come across clearly in the final example. I'm using commas, spaces and things around the specifiers. Back in the dummy actor source file, remember we had previously declared an F string in the constructor. I will cut it out, delete the C string since we won't be using that. Paste our F string in the beginplay function. I will put the S specifier in the text macro like this. Following the closing parentheses of the text macro, I can put a comma and then the greeting variable. If we build now, we will get a strange error, something about invalid arguments passed. That's because the S specifier needs a pointer to the string, not the f-string object itself. It doesn't work when you pass it some object, it needs the pointer itself. So as I mentioned in the slides, we will use the overloaded asterisk operator, which will kind of make this look like dereferencing. If you go to definition with the modifier key enabled, you can just control-click on the operator to go to the definition. This option is in Tools, Options, Text Editor, and General. Check this option, enable mouse click to perform go to definition option, and select the modifier key. In this case, I will use the control modifier. Click OK. Now back with the file open, if you hold that modifier key, in this case the control key, and left click on an identifier or an operator, such as the f-string type, it will take you to the definition for that. I will control left click on the asterisk, and that will then take me to its definition. So that is a shortcut for the context menu go to definition option. We are not really concerned with what is going on behind the implementation of these things. I just want to demonstrate this so that you can see why we have to use the strain syntax, since it can often be confusing if you have to use strain syntax and you don't really understand why. Once we understand why we have to use some strange, confusing syntax, it often just makes sense and we can understand that it actually saves us some time. This operator, as we can see, is defined in the unroll string header. It is going to return a pointer to a tchar constant. In the definition, so in the body, we have the ternary conditional operator. The check is if data.num. Now remember I mentioned that the data in the f-string is a t-array of tchar characters. So the num member function of the t-array is actually going to return the number of elements or characters in the array. If the array of characters is not empty, then do data.getData, which is going to return a pointer to the first element, so the first array entry, which is what the S specifier requires. Otherwise, if the number of elements is 0, then it is going to return an empty string, which is formatted with a text macro. Again, we will discuss the t-array in more detail in a future lecture, but basically why this can get confusing is the num function and the data.getData function. Those are t-array member functions, not f-string member functions. It also makes sense to some extent why they use this operator, since the referencing a pointer fetches the value stored in the object where it is pointing. Similarly, using this syntax, we fetch the pointer to the first array entry. Maybe that will help you remember what is going on. So as we can see, this is not that difficult. It is simply how these things were implemented, and we simply have to familiarize ourselves with how to use these things, as we would when learning any new framework. Again, the details are not important for us to remember, just that we need to use the syntax when we want to log an f-string variable when using the S specifier, because again S does not accept an object, it accepts a pointer to a string. I will build and run that. Back in the editor I will apply my filters again, but this time I will also filter the verbosity to show only messages, that is for the display verbosity. Notice that we get our string in the log. Back in Visual Studio, let's change the greeting identifier to name, and I will initialize that to Bob, for example. Now when we log, I will print hello, comma, the S specifier, and following that to the exclamation. I will also make sure to change the greeting to name, since that is now undeclared. Now we can actually hit Ctrl Alt F11 from right here within Visual Studio to rebuild with that live coding feature. And now our filters will remain, so that saves us some time. I will playtest and we get those hello Bob printed. Remember that we have two of those objects in the level, which is why we get this printout twice. Back in Visual Studio, I would like to mention that if you do not have that go to definition enabled in the tool options, then you can always select the particular type of operator that you would like to go to definition for that. You can select that and then right click, and then you can go to definition, or you can press F12 as the hotkey for that. So that will also take us to this definition. You can also place the typing caret right before the operator or type, and then right click and go to definition, or use the hotkey again, that is F12. But if you place the typing caret between the operator and that name here, for example, it's actually going to take you to that f-string and name definition and not to the operator. So do pay attention to where you place the typing caret. That is if you do not select the actual type or operator that you want to go to the definition for. Alright, so that is just a quick tip on that if you do not have that go to definition enabled for some reason. Back in Visual Studio, in the Solution Explorer, we can search for core globals, that header, and open that up. We will notice that this is where those categories are defined using this declare log category extern keyword. As you can see, those belong to the core API. We have log core, for example. We've seen some of these in the logs before, log load, and here we have log temp as well. We can actually define our own categories, but we are not concerned with that for this module. Again, we want to learn how to use the existing stuff, and then in future modules we can always explore how to set up more custom things. And with that, we are going to wrap up this lecture. I know it was on the longer side, so I have moved some of the additional discussions on the F-string out to upcoming lectures. Logging is essential for debugging, and we will see more examples on this moving forward.